guys, and welcome back to another video on the channel. In today's video we're going to be going over question 4 from the QCAA Physics External Exam for paper 2 from 2021. Now you would have noticed with all the videos on the channel I've started splitting up all the questions into individual videos. That way if you only struggle with a certain type of question you can go watch that certain question on a video rather than sitting through the full exam. The full exam is still up on YouTube, however I've given this as an extra thing as well. And I can also go into a bit more depth on each question as well. If you guys need a physics external exam bundle pack, there is a link in the description below to get your download. And if you have any questions at all during the video, leave something in the comments or send me a direct email and I'll try my best to answer it. Alright, let's get straight into it. So, question 4. A spacecraft is located between two large asteroids, asteroid A and asteroid B, and they are 120 kilometers apart. Asteroid A's mass is approximately 4 times the mass of asteroid B. Determine the distance of the spacecraft from asteroid B if it experiences no net gravitational force from the two asteroids. Okay, so this one here, first of all, let's understand the situation. You have asteroid, now which one is bigger? Asteroid mass is 4 times the mass of asteroid A. So this is asteroid A, and this is asteroid B. 4 times bigger, okay? So let's say this is the mass, this is 4 times the mass then, okay? Now, regardless if there is no spacecraft, there would be a gravitational attraction between these two things here because of the mass, using Newton's law of gravity. So force equals the gravitational constant times by the product of the masses divided by the distance between them squared, something like that. Now, if we want to know where there is no net gravitational force, that's going to be a little bit different. So if we were to think of it like this, as soon as we have a quote-unquote third object in here, so the spacecraft here, there is going to be a gravitational force going this way and a gravitational force going this way between the two objects, okay? Now, in order for it to have no net gravitational force, this has to be equivalent to this. Now, because the mass is bigger, that means the spaceship is most likely going to be closer to asteroid B in terms of like this situation here, because mass affects it significantly. So in order to counterbalance it to have equal forces, this has to be closer here. Now, let's understand the distance between them. They've said it's 120 kilometers. Now, we have to convert that to SI units. So 1 kilometer is 1,000 meters. So when we have 120, we have to times that by 1,000. So we can write that as 120 times 10 to the 3 meters for the distance. Now that will be important here. Now, in order to work out where there's no net gravitational force, we have to name some things. So here, if I were to call this distance x, so x is the distance between the spacecraft and asteroid B. This distance here would be 120 kilometers minus x then, okay? So let's set this up. Now, what we also have to do is we have to account for the mass of the spacecraft as well. So we'll call this, we'll call it capital M in this case here. We don't need to name these guys differently because we know how they relate to one another. And I think without that, we wouldn't be able to answer the question. So we have the force of gravity between asteroid A and the spacecraft. So that would be the gravitational constant times by the mass of asteroid A, which is 4m, because I'm going to write in terms of asteroid B, times by the mass of the spacecraft, which is that, divided by the distance squared. So the distance squared would be this guy here, 120 times by 10 to the 3 minus x, all squared. Now we also have the force of attraction between asteroid B and the spacecraft, which is the gravitational constant times by the mass of the asteroid times by the mass of the spacecraft divided by the distance between them, which is just x in this case, getting squared. Now, because they said experiences no net gravitational force, what we can assume is at this certain distance, the force of asteroid A to the spacecraft has to be equivalent to the force of asteroid B to the spacecraft as well. So we can equate these guys here. Now you might be wondering, oh, how's that going to solve anything? Well, a lot of stuff will actually start to cancel because we've got a lot of things in terms of one another. So here if I move this away and I make them equal to here, you will have this. G times by 4m times by capital M over 120 times by 10 to the 3 minus x all squared equals G times by M times by capital M over x squared. Now this is where naming it would have been very important at the start of the question, but because we've done it here, it'll be quite easy. So here we can see we can cancel the lowercase m from both sides, the capital M from both sides, and the gravitational constant. So we only have this equation to solve. 4 over 120 times 10 to the 3 minus x all squared equals 1 over x squared. Now, because we're in physics, you can use the solve-n if you'd like for that, to solve for the answer straight away. However, because this is a video, I'm going to show you a quick way to do it. So first of all, I would flip both equations upside down so the x squares are going to be on top. So I'll have this on top, 120 times 10 to the 3 minus x all squared over 4 equals x squared. What I'm going to do now is I'm going to square root both sides to cancel it out. So when I square root both sides, that will cancel the top bit. So you have 120 times 10 to the 3 minus x over. Now if I square root 4, that's going to turn to 2. So I have 2. And then I've got x here. What I'm then going to do is multiply both sides by 2 in order to get the 2 out of the denominator just there. So, what's going on here? Let's try that again. So I have 120. Oh, it's doing that again. See if this fixes it. Hopefully. Okay. So 120 times 10 to the 3 minus x equals 2x. Move the x to the other side. So you have 120 times by 10 to the 3 equals 3x. So the distance is going to be 120 times 10 to the 3 divided by 3 in meters. So whatever that's going to be, if I can work it out in the calculator here. So it's going to give you x equals 40000, and this is all in meters. Okay, so what is that? 40,000 meters. That doesn't. Oh, actually, yeah, that might seem right. What's that in kilometers? 40,000 divided by that. So 40 kilometers. Yeah, that seems right. Sorry, I had to sneeze, so I had to mute the microphone. Okay, so that is the distance. Now, they probably want an SI unit, so you could probably write it like that, or you could write it like that. But that is the distance from the spacecraft to asteroid B. Now, notice they said between the spacecraft and asteroid B. If they wanted the other way, you'd have to work out this distance. Okay, if you have any questions about this one here, leave something in the comments. If you guys need a physics external exam bundle pack, the link is in the description below. But otherwise, I'll see you guys in the next video.